We're going to use the ratio test on 1e, and if you notice that it is an alternating series, so that's a good sign. Okay? And we have a factorial in the denominator, so that's another pretty good sign that of convergence. So we're going to set up our ratio test. So we end up with -1, -1 to the power n plus 1, and then x to the power n plus 1 over n plus 1 factorial. Okay, in the denominator, we're going to end up with -1 to the n, and we'll have x to the n over n factorial. Okay, so we're going to have the limit as n approaches infinity, and we're going to group some of these terms so that if we group these terms here, the -1 terms, we're going to cancel the -1 to the power n's cancel out, so we end up with a -1. So I'm going to have a -1 term left over from that. Okay, I'm going to group my x's, so I'm going to have x to the power n plus 1, so I'm going to have my extra x here, and I'm going to group that with x to the n. Okay, so that's going to get grouped together. And then the n factorials, I end up with n factorial, and in the denominator, I'm going to end up with n plus 1 times n factorial, and then I'm going to group those as well. And put the absolute value around everything. And then I can start canceling and simplifying. So a few terms cancel out here. So we'll cancel out the n's, x to the n's. The n factorials will cancel out here. So this is equal to the limit as n approaches infinity. Okay, so what's left over? We end up with x, and this is all over n plus 1. And then at this point, we're going to let this go to infinity. So as n approaches infinity, no matter what x is, since x is finite, because x represents the domain values, since x is finite, this is always going to be less than 1. This will be the case for all real numbers. So this is for x is all real numbers. Okay, so we have an infinite radius. Okay, it's good for our radius is infinite, and our domain ends up being all real numbers for this particular function.